Okay, welcome back. I'm Mr. Winup, your grade 10 maths teacher. Right, in our last lesson, we were looking at finding angles. Today's lesson, we're going to look at angles of elevation and depression. Okay, so let's look at angles of elevation and depression. Okay, angles of elevation and depression. Now, where do we find angles of elevation and depression? Angles of elevation and depression are formed in trigonometry when you are looking up at something or when you're looking down at something. Okay, so let's illustrate this. For instance, we have your eye here, okay, and we are looking up at a bird that's flying up in the sky, okay? So, where your eye is looking at the bird, this is your line of sight, okay? So, your line of sight forms an angle with the horizontal, okay? Your line of sight forms an angle with the horizontal. This is known as your angle of elevation, okay? Angle of elevation, okay? Now, again, looking upward at something forms angle of elevation with the horizontal. Now, if you are looking down, okay, in a downward direction, this also forms an angle with the horizontal. Let's say this is a cat. Okay, there we go. This is what we did in primary school. We are looking at a cat. This is now your line of sight, okay? Your line of sight. And your line of sight forms, okay, an angle of depression, okay? So line of sight forms an angle of depression with the horizontal. Okay, so there's your angle of depression. Okay, so angles of elevation and depression are used in finding height of buildings, okay, or the distance between two places. Okay, this is very important. Usually we would not pull, say, tape measures and whatnot between two villages to measure the distance. No. Okay, we would use angles of elevation and depression to help us find the distances and the heights of tall buildings. Okay, now let's illustrate some of these angles of elevation and depression. Okay, let's see. One example showing an angle of depression. Let's say we have a lighthouse. Okay, this is our lighthouse. All right. And our lighthouse, we have the keeper of the lighthouse who's at the top of the lighthouse, and he's looking down at a boat out at sea. Okay. Now, as this keeper is looking down at the boat, okay, looking at the boat, his line of sight is forming, all right, an angle of depression. Okay, so here's your angle of depression. We have the lighthouse keeper looking down at the boat, forming that angle of depression. Okay, Now, another example would be, okay, let's say we have a building and somebody who comes down to town where there are lots of tall buildings and is just in wonder looking at these buildings, okay, young girl. So she's looking up at the top of the building, and just in amazement at how tall the building is, okay? So she's looking at the building. Her line of sight forms this angle of elevation right there. Okay, so look at the direction in which our arrows are pointing. This is an angle of depression, and this is an angle of elevation. Okay, now where do we use the angle of elevation and depression? We are going to go through one example to show us how we use the angles. Okay, now let us imagine in a park we have two flagpoles, okay, which are 20 meters apart. One is taller than the other, okay, so the shorter flagpole is 12 meters in height, and the taller flagpole is 27 meters in height. Okay, so let's put that up on our board and see where we can put in our angles and distances. All right, so two flagpoles, right? One is shorter than the other. All right, so here's our short flagpole, and 20 meters away from this flagpole, okay, 20 meters away, we have the taller of the two flagpoles, okay? The taller one is 20 meters away from the shorter flagpole. Okay, there we go. So this short flagpole is 12 meters in height, and the taller one is 27 meters in height. Okay, now the question is, what is the angle of depression from the taller flagpole? Okay, what is the angle of depression from the taller flagpole? Okay, so we need to find that angle. All right, you already know how to do this. We just need to show it in our diagram so that we can work it out. Okay, now from the taller one, so let's draw in the triangle that's going to help us find that angle. All right, now once you have drawn this, remember, go back to our diagram. Angle of depression is formed when you are looking down at something. Okay, so this can't be the angle of depression. No. So we are going to have to draw in another horizontal line to help us put in our angle of depression. Okay, so let's do this. There we go. There's our horizontal. Make sure that this is parallel to this one here. Okay, and that's our angle of depression. Okay, so now that we have found the angle of depression, we don't know how many degrees it is, so we will represent this with theta. Okay, now let's see. Form your triangle. Okay, this is right angle. All right, now the distance from here to here is the same up here. So let's put 20 meters up here as well. Okay, the distance from here to here can easily be found because we know the measurement of the tall flagpole and the shorter one. So 27 minus 12 will give us a distance of 15 meters. Okay, now that we have the information in a diagram, it's easier to see what ratio we are using and how we can find that angle. Okay, so Hypotenuse is unknown, which strikes out using the cosine ratio and the sine ratio. Okay, that leaves us with tangent ratio, which is the ratio we are going to use. Okay, so tan of theta, which is the angle of depression, is equal to opposite side, all right, over the adjacent side. So opposite in this instance is 15. Our adjacent is 20. Okay, now theta is equal to, we have to divide here so that we are able to find the tangent value. Okay, so 15 divided by 20. Okay, 15 divided by 20. 15 is less than 20, so we write 0 here first. 0 times 20, 0. Okay, bring down 15. Okay, now we put our decimal point at 0, bring it down. Okay, how many times will we multiply 20 to give us 150? 7 times. Okay, so 7 times 20 will be 140. Okay, we have a remainder of 10. Add another 0, bring it down to make it 100. Okay, so 5 times 20 will give us 100. No remainders. Okay, now 0.75. So theta is equal to tangent value of 0.75. Okay, now as we did in the previous lesson, once you reach this point, you need to take out your textbook, okay? Then go to your trig tables and identify the tangent value 0.75, okay? 0.75. According to our tables, okay, 0.75 tangent value is closest to 2 angles, okay, 2 angles. We have 1036 degrees, okay, which is equal to 0.7265, and 1037 degrees, which is equal to 0.7536. Okay, so the closest tangent value to 0.75 is not 36, it will be 37 degrees. Okay, so the value of theta is 37 degrees. Okay, 37 degrees. Right, so we go back to our problem. The question was, what is the angle of depression from the taller pole to the shorter one? Okay, so our answer is angle of depression is 37 degrees, okay, from the taller flagpole to the shorter flagpole. Okay, right. In the next, this wraps up this segment of our lesson. In the next segment, we will have a look at another example of angles of elevation and depression, but slightly different to what we've seen here. Okay, thank you for your attention. I'll see you in the next segment.